Hello everyone, I'm Alicia Knighton and I'm an ecosystems engineer here at Honeycomb. Today I will be discussing with you build events using GitHub Actions. So what's on the agenda today? In this user enablement training, you will learn about build event requirements. So I will take you through a getting started process, basically from 0 to 100. From there, we're going to create a simple span, create more spans, as well as add high cardinality data. Next, we will look at the query builder to query the data to ask questions about the build. Finally, we will use the starter pack to create boards using Terraform. So what are build events? Build events help you instrument your workflows using Honeycomb's build event tool. So with this tool, it's going to populate the trace with the metadata from the GitHub Actions environment, and it will always send a trace for that build, even if that build fails. And so if you look at it this way, if you've seen tracing data before, with the trace, you're going to start somewhere. So in this case, we're going to start from where that build starts. And at a very simple level with that build, it's going to be watching to see how long that build takes and give you that information back. From there, you're going to create manual spans for each step along the way, if you so choose to. And so build events is basically a small binary used to help generate that trace telemetry. And there's a setup phase. And then from there, it's invoked part of each step in the build to capture. At the end, what you'll get is a trace waterfall. And so if you look at this trace, it looks no different than any other trace. There's 3 modes. There's a build mode, and that sends the root span for the entire build. And with GitHub Actions, this is automatically generated. After that is the step mode, which represents a block of related commands. With that step mode, you're going to do what you normally do in your step, and then you're going to call out the trace ID. And then from there, there's going to be a step ID. Normally, that's readable context. You can make that a hash, whatever you want that to be, but that's going to identify what that step is. And then there's going to be a start time, so we know how long that thing takes. And then there's going to be a step name. And traditionally, people use the readable step ID to also say that this is a step name. And then the second part of this is you can do step mode, or you can actually do command mode, which invokes the individual command as part of the build. Let's just say you're running an npm install. In that step mode, you would see how long that took. In that command mode, you're now able to see what command was actually done during that process. And so that gives you more insights into what's being done under the hood. So it's the same command as a step. With that command name, you're going to have a dash, which represents command that I'm going to run after that. So let's just say I'm doing an echo. I would have dash echo hello world after that. There are a few requirements. You definitely need a Honeycomb key. It needs to have permissions to send events, so it can send to its designated dataset. By default, we create a build events dataset for you if you don't provide a dataset. And if it has not been created, your permissions would also need to also include creating a dataset unless you create that yourself. From there, GitHub definitely needs access to your environment. So you're going to use the GitHub Action secrets located in the settings of the repository. And you're going to use the label build event API key. That's what tells build events, hey, use this key. And then of course, you're going to need a workflow YAML to do your CI work. Now is example time. I'm going to switch screens to go over example from start to finish. Hello everyone, so I'm back. On the left hand side I have my browser, and on the right hand side I have VS Code. Let's look at a few prerequisites. The first thing you need to do is to go into Honeycomb and get your Honeycomb API key. In order to do that, you would need to select the environment. And then from that environment, you would need to select Manage Environments. After you select Manage Environment, you would then view API keys and retrieve the appropriate API key. From there, we would then move on to the GitHub repository. Within that repository, you would select Settings. From Settings, you would then select Secrets and Variables and Actions. Within the Actions, Secrets and Variables, you would then select New Repository Secret, in which you would name that Build Event API key, and then you would put your API key in that secret. And so by doing so, GitHub Actions can now talk to Honeycomb, in which it would be able to send that information for you to query on. Let's migrate over to the CI YAML. In this YAML, we have a Node.js application, which it will install some dependencies, perform some smoke tests, as well as a few jet tests. To get started, we will utilize GitHub Actions build events at the beginning of our steps to capture the initialization and the end of the workflow. To do so, we will say uses honeycomb.io /GHA build events version 2.1. To utilize GitHub Actions with Honeycomb, you need to point to that API key is in secrets. And then you're going to point to build event _ API key. You also need to select the appropriate data set. I'm going to select Buildevents GHA integration. If that data set is not already created, the API key needs to have permissions to do so. Job status will allow Buildevents to send the status of the trace. If a job succeeded or a job failed, Honeycomb will know about it. So that's step 1. Let's create a span for each portion of the workflow. I'll look at line 25, which is using the actions setup node. Since that's a third-party action, it will need to be in a separate step from the actual build. To invoke that build command, we will need a few pre-step configurations. I will name this step starting Node.js setup. Within this step, I'm going to echo in the step ID and echo in the step start time. I need to echo those into the GitHub environment so it can be exported after it's finished. The step ID is the steps identifier. You can use human readable text or randomized identifier to identify each step. If you use the step ID as human readable text, then you can also use that same step ID for the step name. We also want to make sure we are including the step start time. By doing so, we know when the step starts. Once we have our variables set up to actually capture the information, now we can tell it, hey, when done, send this information to Honeycomb. I will name it finishing Node.js setup. In the run, we're going to invoke the build event step command. The trace ID is the unique identifier that Buildevents sets for you. That step ID is what we verified in the starting Node.js setup, as well as the start time, which is the step start in this case. And as previously indicated, I'm going to use the step ID as the step name. So now we have a span which will indicate when the third-party action has done its job. In the next job, we will install dependencies. So in this run, I'm going to set the step ID as well as the step start. I will name it installing dependencies and provide it with a start date and time to send that information right to Honeycomb. And so now we have a span for installing our dependencies. Let's say you want to create subcommands. Let's use the build command for that. We set up our step ID and our step start as we've always done. What's different about using the build events command is that we're going to use syntax that will allow us to see the specific command ran. Using build events command, we're still going to call out the trace ID and the step ID because we need to know what trace it belongs to. We need to know the step identifier. We're going to give it a name. I'm going to refer to it as sleep. And then I'm going to use the dash to identify that everything following that dash is the command I want ran. I need to fix this. And then we're just going to copy and paste that for the additional sleep command that we're going to run. Those are the two subcommands happening. And now we're going to say that the sleep 18 will appear at the top level of the smoke test. So what you will see is that the sleep 8 is at the top. Nested within that will be a sleep 6 and a sleep 2. To do that, I would just add the step command. For this last portion, I will gather information from the just test. You can use build events to provide additional context to Honeycomb automatically. There may be key results that you're getting from your build that is important to ask questions about. In the case of the test that I'm running, I may want to know how many tests ran, how many passed, how many failed. It can be whatever you want it to be. Send as much custom context as you desire, and you will need to point that to a build events file. Currently, I actually have a build events file within my repository that has additional context that may be important to my business. To perform this, the pre-setup is the same. You're going to need a step ID and a step start. In addition to that, you're going to also need to add a build event file. You can create one on the fly if you like. When I run these tests, I will need to create the variables and echo them into this build events file. To add fields into only this span, if I wanted to, I would need to override the build event file in a single step. Since I haven't used this file before, I don't need to do that. I've added a few fields in here. When the test is ran, it creates a just log file. I'm going to cat that log file and create variables from that. And then I'm going to echo those variables into the build event file. The important part here, I will highlight it. If you notice, every time I echo in, I add a space because the file itself uses spaces as the delimiter. So add that in to make sure you're not having collisions with your variables and things. Finally, we're going to send the just test span along with some of that custom context or high cardinality data right along the honeycomb. Before I submit this, I'm going to make sure my variables and everything are okay. Okay, let's go off and look at what's going on in Honeycomb. We can click home and here's my recent trace. If I click into this trace, there's a few things going on. So this is a trace waterfall and it's reflective of our build. If you notice, we have the build plus where repository is coming from along with its CI number. And overall, it took 49.47 seconds to actually run. And then from there, we can see where it initialized and where it ended and post to Honeycomb. And in between that, we can see the custom spans. So I see the setup node I created along with the time. I see installing dependencies. I see the smoke test and I see the jest test. And within the smoke test, I see the 2 sleeps that I created. As I highlight over, I don't know if you notice on the right hand side, but there's slight changes just because at Honeycomb, we show you all of the fields as they pertain to the span that you're selecting. So in this case, this is the sleep 6 and this is the sleep 12. And so now that I see those, I can see the difference and actually how long they took. So they took a little bit over 6 seconds and 12 seconds, which is expected. And then overall, to process this took even longer time. When I go over to the jest test, I'm able to see what tests passed, the total amount of tests, how many tests failed, as well as the other custom contexts such as team name and file location. Using build events, I now understand what's happening with my build. So we created spans using different techniques, and that's cool, right? But what's next? Why would I need to use this anyway? So let's go to new query. On the right-hand side, we can see a schema, which is all of the information that came in. So the things that we're obtaining from GitHub Actions, as well as that custom context. You can also do things such as add descriptions. So here I've added a description so my team knows this is what this field actually represents. And if I want to, from there, I can query on this field to show me, hey, in the last 2 hours, show me spans where this actually exists. I can actually click on this to see where this field actually exists and go right to it if I like. So I'm going to look at the data from the last 7 days and simply run a count. And from that count, I can then group by job status. And so looking at this, I can exclude places where the job status does not exist. And then I can go and look at failures or success to see why. I can also add things where there may be additional context. Remember I looked at those tests earlier? Now I can go over here and say, hey, show me where this test failed or where there were tests that failed. Oh, it says that the job status is a success. Well, this is my demo environment, so I know that. But this may be a way to say, oh, well, I have failed tests here. Maybe our pipeline should fail, or maybe something's happening. You can be more inquisitive about what's going on. You've just gotten started. You've touched the surface on what you can query and how you can query. Is there a quicker way to get started or just a few starter queries? Well, you're in luck. We actually have a Honeycomb Build Event Starter Pack. Using Terraform, you can auto-magically create a Honeycomb board for your build events. Boards are a way to group queries together that you may commonly run, that you may need as a starting point. I will show you how it works. First, we will just point to the module, which is Honeycomb Build Event Starter Pack. I'm getting the latest version. I've identified the Honeycomb dataset. If you don't, then it will default to build events. There's also the query range. which is in seconds. By default, it defaults to 7 days. Also, there's an ideal build duration, which defaults to 2 minutes. Last but not least, you will need to export your Honeycomb API key or set it via a variables file. Now you can initialize via Terraform init and then Terraform apply. Now you should see that 6 resources have been added. And now let's go and look. I now have a board named Explore Build Events. I have a heat map of durations, what times are slow, and I explore any patterns. I can select these, and if this does not match with the durations that I'm looking for, I can always change this. And once you change it, you can simply update the board. Or you can update it via Terraform, which is what I would recommend. So we've added some spans to our workflow. We've queried on some interesting things. We've even added custom contexts and automatically created boards via the Honeycomb starter pack using Terraform. So that's all. Thanks for joining.